In this video, we're going to continue solving quadratics, solving for x when given a quadratic. The last few videos we graphed it and we looked at the x-intercept. That's what x was. Wherever the parabola crossed that x-axis, that was what x equals in a quadratic. This time we're not going to be graphing it, we're not going to be looking at it visually, we're just going to be solving it using our algebra. So algebraically solving quadratics. There's a lot of different ways to do it. We're going to just talk about the basics first and then get into some methods here. So one thing we need to keep in mind is this thing called the greatest common factor. And we're going to shorthand it as GCF. So anytime we break something down into its multiples, let's say 48, if I break that down, it could be 8 times 6, it could be 12 times 4, there's many ways to get it started, but eventually we factor it all the way down to what are known as the prime factors. And we can create a prime factor list. 2 times 2 times 2 times 2 times 3. If we were to do that multiplication, we would get all the way back up to 48. So remember, GCF, greatest common factor. If we want to find the greatest common factor between two numbers, creating our factor list helps a lot. So if I want to find the greatest common factor between 48 and 120, well, we make factor lists, break it down into their prime factors. I like to circle them. And then we can write our list. I'll write it down here. 2 times 2 times 2 times 3 times 5 gets us back up to 120. And if we take their prime factor lists, what they have in common in their lists, and multiply them again, we get the greatest common factor. So let's see here. This list has 1, 2, 3, 4 2's, but this list only has 3 2's. So we can only circle what they have in common. So let's only circle the 3 2's there. They also share a 3. So let's circle that as well. Let's take one of those lists. Let's just look at one and multiply it out. 2 times 2 is 4. 4 times 2 is 8. And 8 times 3 is 24. So 24 ends up being the biggest number that fits into 48 and 120 evenly. So that's called the greatest common factor. Now let's take that knowledge and let's apply it to quadratics here. So the reason we like to GCF things, take out their greatest common factor, is it simplifies things. It allows us to solve a problem much easier. So for example, if I have 48 minus 24, now that's semi-easy. Some people might be able to do that in their head. But if I simplify it, I bet more people would be able to do it in their head. If I take out the greatest common factor, the number that goes into both of these numbers evenly, the biggest one, the largest one, then it somehow reduces everything and simplifies it to smaller numbers. So let's do it. The biggest number that goes into both these, if you don't know, is 8. Sorry, bigger than that. I don't even know. It's probably 24, huh? 24 is going to go into both of these evenly. And it's the biggest one that does. So if I take out 24, then 24 goes into 48 twice, right? And 48 goes into, 24 goes into 24 once. And now using our PEMDAS rule, our order of operations, 2 minus 1 is 1. And then 1 times 24 is 24. So 48 minus 24 is 24. Now using this example makes it seem silly, like why wouldn't you already know that 48 minus 24 is 24? Some people don't. That made it a lot easier, right? But some people, maybe that was just ridiculous to do. Well, if we increase our problem and we start adding more complicated things to it, such as expressions where we don't even know what x equals yet, then we can simplify this so that it's easier to solve once we know what x is. So again, we're getting to that point where we're solving for x. So if I take out the greatest common factor, 2, that leaves x minus 3. 2 times x is 2x, and 2 times negative 3 is negative 6. So you can always FOIL or distribute. We'll get to foiling. This is just a distribution. and you multiply it through. That gets you always back to the beginning. So it's a good way to check to make sure that you factored correctly or took out the greatest common factor correctly. So again, let's keep making things complicated here. And you will start to see the benefit of factoring much more clearly. 4x plus 32. Well, if we take out the greatest common factor, 4 goes into each of them. It's the largest number that does. 4x divided by 4 just leaves x, and 32 divided by 4 leaves 8. And again, distribute to get back to the beginning. 4 times x is 4x. 4 times 8 is 32. So again, if we knew what x is right here, then it will allow us to solve this expression, at least hopefully, far quicker than if it was in the bigger form. Again, more complicated. Now we're going to start factoring quadratics. This is eventually going to help us solve for x. So now that we have a second power here, now that we have a quadratic, factoring becomes essential to solving for x. If you would like to take out the greatest common factor, we can simplify it. We can actually get rid of this square right here. And that's going to leave us with a power of 1 for x, which is always what we want. We always want x or any letter to the first power when we're solving for it, right? So let's take out the thing that they both share, the biggest thing that they both share. Well, 5 could go into both of these numbers evenly, but they also have an x. So let's take out a 5x, or divide each of these terms by 5x. If we do that, we're left with 1x, right? 5x times x would bring us back to 5x squared. We got positive 30x. That divided by 5x leaves us with 6. 5x times 6 gives us 30x. So we can distribute to get back to the beginning and check always. Now again, check it out. We got x to the power of 1. We got rid of our quadratic, our square there, and now we have x to the first power. That's always what we want. This is where we begin to see how we can solve for the x-intercepts. If we can solve for x, we know exactly where our parabola, whether it's going this way or this way, is crossing that x-axis. Sometimes it's going to happen once, sometimes it's not going to happen at all, and sometimes it's going to happen twice. So we'll begin to see those examples a little later on. If you remember our standard form, it's the standard form of a quadratic. If we set that standard form equal to 0, that's saying that really y, that's usually where y is, right? That if y is 0, well that's, again, telling us where the x-intercept. If the y-axis is at 0, then that's exactly where we're able to tell where these little arms of the parabola cross the x-axis, where y equals 0, right? So if we set the quadratic equal to 0, we can solve for x. So if we take this factored form and set it equal to 0, we can actually solve for x now. And if you just briefly think about this, if x was -6, just think about that. If that was -6, what would happen right here? This would become 0, right? Always combining opposites gives you 0. And then anytime 0 is going to give you 0, right? So no matter what this x is out here, 5 times it multiplied to that 0 is going to give us a 0. So if x equals -6, then we know that y will be 0. We know that's at least one of our x-intercepts. So there's an introduction right there. Now, one more method. I think we can squeeze it in here. Let's try it. More quick method. If you have a quadratic, here's the generic form, the standard form. And if a, right there, if a is equal to +1, then we're allowed to use this method that I'm about to show you. It's called the X technique. X technique is kind of just a visual method. It's not necessarily anything special. You could definitely solve this using the same technique without an X if you were able to visualize it in your head, but the X kind of helps you keep organized here. So let's come up with a quadratic here. We're going to solve for x. We're going to see how many solutions there are. So in the bottom of this little x shape, what you do is you take a, whatever a is, and it's always going to be 1 in this form, and you're going to multiply it to c, whatever c is. So actually you can simplify it and just say that you put c down here in the bottom. Whatever c is, put it in the bottom. But I don't want to get you too confused, because later on we are actually going to be multiplying a times c. So just get in the habit of saying, well, a is 1, so that times c is going to be whatever c is. So c goes there. It's c, a times c, right? Up here is going to go whatever b is. So that's positive 6. And then on the sides are going to go factors of whatever a times c was down here that add up or combine to get or make b, whatever b is. So that's going to be on the other side as well, both of these sides. So let's think about it. Factors of 9 that add up to positive 6. Well, factors of 9 are 9 and 1, and 3 and 3. Well, 3 plus 3 gives me 6, and 3 times 3 gives me 9. So those are going to be the factors that I use. So we put 3 there, and we put a 3 over here. And what I do right here is I always put my variable to the first power. Same thing over in my other set of parentheses, the variable to the first power. And then I'm just going to put the numbers that I came up with right here. I got positive 3, and then on the other side I got another positive 3. So supposedly if I factor x squared plus 6x plus 9, I get x plus 3 times the quantity x plus 3. And I can always check it to make sure that I get back by foiling. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And then 3 times 3 is 9. If we combine like terms, we get what we started with, right? All the way up there. So this is going to help us. This factor pair right here, x plus 3 times x plus 3, if we set that equal to 0, we are going to be able to solve for x. What can x be here to make this whole thing equal 0? Well, it's got to be the opposite, because that would always give us a 0, right? And a 0 times anything is 0. So always look for the opposite of what's in our parenthesis with x. So there's a positive 3, so x must be negative 3. If x equals negative 3, then y equals 0, and that is where an x-intercept happens. It just so happens that it's the same. So really, we're talking about that being the vertex, right? Here, I'll draw a little picture. Let's look at it graph-wise, right? So at 1, 2, 3, here's our x-axis. Here's our y. So at x equaled 3, that is where the vertex, right, of our parabola that opened up, because a was positive, that's where it touches the x-axis. It only happens once. We saw that there was x only had one solution there, negative 3, right? X equal negative 3. Sorry, negative 3. So we should be over here. 1, 2, 3. There we go. Get rid of this. X was negative 3, right? The opposite of what was in the parenthesis. Alright, there you go. So we're solving for x. Visually, it's wherever the parabola is crossing the x-axis. Sometimes it only happens once, in which case that's a vertex. Sometimes it'll happen twice, in which case it'll look something like that, or upside down. There'll be 2 spots. Sometimes it won't happen at all. If the parabola is down here and it's never crossing the x-axis, we will see what that looks like algebraically. Alright, a few more videos to come on this.